Okay, we are recording. Hello, my name is Sergio Garcia. This is my video explaining just a few important things that are kind of crucial to understanding chapter 6. So I'm going to start with like the main topic, I guess, the equation of the chapter, really. And that's discussing work. That's our primary focus today. So I have its foundational equation written right here, which is your work is equal to your force times your displacement times cosine theta, where cosine theta is the angle between your vector and your displacement. So the way this works essentially is, let's say that you were going, follow my mouse here, because I don't really have a pen. The way it would essentially work is when you are moving an object, essentially what happens is you have the distance, which is your s that you are moving. It's your displacement, right? Your change in x is your s, right? So when you move in one direction, typically there is a force that's applied in one direction to the object as well. So in a situation where you were to, let's say, move a box, push it like 30 meters, right? That means your displacement's going to the right, 30 meters to the right, and the force you're going is also going to the right. So in a situation like that, let's say your force was 50 newtons and your displacement was 30 meters. Since we know that they're both going in the same direction, that means that it's cosine of 0, right? Because if you're going on the same line, that means that the angle between the two vectors is 0. And like mathematically, that makes sense because the cosine of 0 is 1, which means that there's no angle that you really have to calculate. So it would just be your force times your displacement. And yeah, that's essentially the point of it. So no matter what, when you get it, you find out which direction your object is going, and then you can find an angle between that and the force applied to it. And then from there, you put that in your cosine. So then you'll have your force times the displacement times the angle between them. And again, if there's no angle between them, that's a cosine of 0, which means that you just multiply them normally. If the force is perpendicular to the displacement, well, that actually gives us another funny thing, because if we know our unit circle, we know that the cosine of 180 is 0, which means that the work produced on that object is also 0 because the force isn't affecting its displacement. So yeah, just a fun thing to know, if you have a perpendicular force to a displacement, then the total work allotted is 0. We can move on to this next equation right here. This is the formula, the base functional formula for how we calculate kinetic energy. Kinetic energy is equal to 1/2 of your mass times the velocity squared. So right off the bat, you can see this is kind of similar to how force is calculated when force is mass times acceleration, but understand that these are two different quantities and values. Another thing I should mention is that work and kinetic energy are calculated in joules. Anything energy related is calculated in joules. Sometimes kilojoules, sometimes, any other variation of joules, but like that depends on the question that you're being asked and how well the numbers like round up together. Typically joules and kilojoules are what you'll normally see, but in general, just joules, kilojoules are just a type of joule. So kinetic energy, K is equal to 1/2 times mass times velocity squared. There's not too much to go into here, just knowing that half of your mass times your velocity squared is equal to the total amount of kinetic energy acting on an object or produced by an object in motion. The way that we relate work to energy is that your total work is equal to your change in kinetic energy, or your kinetic energy final minus your kinetic energy initial. So if you find the initial kinetic energy using this formula and then do the same for the final kinetic energy, you can find its work total by plugging in those two numbers and subtracting your initial by your final, and you'll get your total work. And that could give you a myriad of other things as well, manipulating those formulas. Next, we have how to calculate work and energy with varying forces. So we're taking a force that's on like the going in the x direction, so right or left. In this situation, it's actually the integral from your initial position to your final position, f of x dx. So essentially you're taking the integral of your force in between your first and last position, and that'll equal to your work between, like, during that interval. This becomes sometimes a bit more complicated in practice, but for general for general questions, it's actually been pretty simple. So the difficulty there is something that kind of ramps up exponentially. Next, we have work energy theorem along a curve. So what this complex thing is kind of more understandable once you look at this, but we'll first talk about this. So it says work is equal to the integral of 0.1 to 0.2 of force dt, which is equal to the integral of 0.1 to 0.2 of force cosine of theta dl, which is equal to from 0.1 to 0.2 force parallel to dl. Essentially what this is saying is something that you can learn in like essentially Calc 1. So what you're doing here is you're essentially calculating the force acting on the tangent line. The line tangent, you see dl is tangent to your 2 points and the angle of the force being exerted on them. So you're essentially making a new angle right here, and then calculating the integral of that force between points 1 and 2. Finally, we have power. So your power average is equal to your change in work over your change in time. So power essentially is just a rate that relates work to time, which means that if you wanted to find work, work would be power times time, or in this case, like a force, or if you wanted to find time, that would be work divided by power. So it's something that we've seen before, like acceleration comes to mind, where it's change in velocity over change in time. So power, your average power, is your change in work divided by your change in time. So how to calculate power initial? So power initial is found in, I guess there's two formulas that can kind of explain it. Power initial can be limit as your change in time approaches 0 of this rate that we found before, which is your change in W over your change in T, and that will equal to dW over dt. And then power initial can also be expressed as your force times your velocity. This will be the easiest way to chip it out when given a word problem. If you find your velocity immediately, then you can just multiply your sum of forces, and that can give you your initial power. And that's essentially like a brief overview of important equations and minor concepts that you'd run into when you discuss chapter 6 and work through it. Thank you, and I'll see you in the next video discussing chapter 7. So thank you for your time.